Hi, Electro here. This is a quick video on my attempt to fabricate the ceramic quenching disc by Stan Meyers. Stan used alumina for his discs in his patents, which is this material here. It's also a high strength ceramic, as you can see, but I don't have this available, but I do have zirconia available, which is actually stronger than alumina. Everything else is very, very similar, so this is the material I'll be using. Another advantage of this material, like alumina itself, but like I said, I've got this on hand, is that it first comes in a compressed powdered form. Now, at this state, it's called the green state. It's very easy to work. It's very easy to cut, mill, and it ends up being like a powder after you grind it, but it's like I said, the consistency of chalk, so you can drill and shape it and everything like that. Now, after that, we'll put it in the furnace overnight. It'll reach 1600 degrees Celsius. It'll maintain that temperature for approximately 4 or 5 hours and then slowly cool it back down to room temperature. Once that's done, it goes from the chalk stage, which is the green state, to the sintered ceramic state. Now, at this stage, this ceramic is superior to the alumina ceramic, which is what Stan was using in the 80s. This is like a newer version, higher strength of it. So anyway, I've cut my discs from my zirconia block. I've cut them to certain thicknesses using my milling machine here. And I'll also show you now what I'm doing is, hang on, I'll turn the light on. I don't know if you can see that, there you go, but first these were cut a little bit thicker, so basically I can trim them down exactly individually to the thickness that I want. Now bear in mind, because of the shrinkage and a little bit of extra surface just to aid finishing of the finished product, they end up being 4 millimeters thick. So what I've got to do is make this 4 millimeters thick after it's complete. Here's one I've prepared before. Here's a thickness gauge that I have. There you go, that's 4 millimeters, 4.2 millimeters thick at the moment. Now, when I thin that down, like I said, after I sinter that and I finish it on emery paper, etc., to get a nice smooth finish, that'll be 1/8 inch thick, and I'll be able to drill it before I sinter it, which will make the process a lot easier, because a ceramic this hard, to drill that fine, like 0.24 millimeters, I doubt you'd be able to do it, especially a 1/8 inch thickness. But in the green state, it's actually quite easy to do. Now, what I'll do now is just continue on milling this disc flat. So I'll just set this up here, so you get an idea of how easy it is to mill. Oops. Yep. There you go. That's now a little bit thinner. That should be approaching the 4 mils. As you can see, at this stage it'll be quite easy to drill. So anyway, when my drill bits come in, I'll do the second part, which is the drilling and sintering and final finishing of the discs. After that, I'll be shipping them to Russ so he can test them, and in the meantime, I'll just have to wait for my drill bits to get here. Just before I go to, I'll run you through this machine. This is my mini milling machine. It's got, as you can see, millimeters set here. Come on, focus. There, so you can set there. It's got a depth set, so it stops it going down. You can vary that height of the press. It's got a magnetic table which you can move again side to side through millimeter adjustments on this side and that side, and it's got a universal table that's like just like that. You can change the angle of and then just set it. Yeah, but this comes in very handy for stuff like this. So anyway, I'll keep you posted. Bye.